Good morning. My name is Robert Schmidt, and I'm the creator of the Authorship Forensics Portal. Although the idea originally was from Dr. Maiga Chang, I developed the front end and the back end of the Authorship Forensics Portal, as well as a view and prediction functionality. So we're going to go through how to use it really quickly and the data sets and what you should make sure that your data sets look like. So let's share my screen here. I apologize. I have to look up to the left because that's where my monitor is. All right. So this is the Authorship Forensics Portal. You can access it by going to the Ngram POS on the VIP research website. So actually, if you just went to the main website, you'll actually find a link here. You can go to Authorship Forensics, and that'll bring you to this page. So here you can upload a data set, and then that data set will be parsed and broken up, put into a database where the POS, the parts of speech will be identified and the combinations of parts of speech will be identified and then put into the database and then extrapolated from the database, and then charts will be created based on the frequency distribution of POS on each document within a data set. And then models will be trained based on that data set so that you can make predictions based on that model. All right, so let's talk about the data sets. You're going to take a look at the instructions up top here. So any format here is fine. Just make sure you stick to one. So you don't want to mix this format here with a title in with a format that doesn't have a title. It may work, it may not work, but it even says here, do not mix the formats. It's probably best not to mix the formats because once it sort of figures out what format you're using, it kind of follows that all the way through. So the easiest and most common sense format to use for most people will be this one here, where you have the label, which will typically be the author name of the body of text, and then the body of text. And I'll show you some examples of other ones, or at least one other one. So here's an example of the data set that we used for the paper abstracts. So you'll notice here that within the first set of brackets is multiple authors. It will pick the first author before the comma, just so you know. So if you've got multiple authors or whatever, it'll always pick the first one before the first comma. So in this case, this would be the label. And then this one here has a title. Title is optional. You don't have to have a title. You don't have to have the second set of brackets if you don't want to, but that option is there because this is kind of the BBpedia style or the TTL style where we have authors, title, text body, and then even a language identifier at the end. So, and this is perfectly fine. This will work perfectly fine. So each one of these documents is actually one row. I will remove word wrap so you can see that. So each one of these is actually one row, and this will work perfectly fine. But optionally, let me open up a different one here. So just to show you, this would work perfectly. This would work perfectly well too. So of course you want a bigger data set than this, but in this case, test would be the label, hey would be a label, hello world is a text, and want cheese is the text. And this would be 2 documents within the data set. Now, ideally, in terms of building data sets, you want to have approximately 5 to 10, at least 5 to 10 authors. If you're doing, so we'll talk about the different classes of model training, but if you're doing human versus ChatGPT, you want to have approximately the same number of human authors as you do with ChatGPT. If you're doing human authors versus ChatGPT 3.5 versus ChatGPT 4, you want to have about the same amount of authors in all 3 categories. If you're doing all authors, if you're doing if you're trying to figure out if you're submitting a whole bunch of Maiga Chang's documents and then submitting a whole bunch of Rita's documents and then submitting a whole bunch of my documents and submitting a whole bunch of whoever, and you're using the all class function, you want to have about 5 to 10 at least of each one of those authors, and you want to have it balanced. So you want to have approximately the same amount in each category. So there should be 10 in Dr. Chang, 10 in Rita, 10 in etc. So good. So now, if your data set is not consistent all the way through, it will check and reject it when you try to put it in. Also, there are a few words that it won't accept just based on what's in the directories, and and what would kind of mess up the parsing. So if you put in a dataset name and it gets rejected, it's nothing you've done wrong. There's probably a reason for it. It could be that there's already a dataset in there with the same exact name. It could mean it should tell you what the problem is. That could mean that it conflicts with a reserved word, that type of thing. You can't if you try to put in special characters here. Sorry, numbers are fine. If you try to put in special characters, it will remove all of the special characters. So that could be a little weird if you put in something like whatever, a bunch of letters, then some special characters that for whatever reason you need them there, and then you did this, it's going to remove all of these special characters and then just squish it down so that it's just the regular characters. Okay, makes sense. So we're gonna make a data set name and we're gonna call it a test. And we're gonna begin by choosing a file. We'll use, I have a data set called Real Data Set with GPT. That's just a small data set with a few human authors and some GPT. So I'll show you what that looks like. Yeah, so it's like this. We've got 5 human authors and 5 ChatGPT 3.5. So we'll be able to build at least a class 2 data set. Let's talk about that. So the options here for model, at the point that you may be using this, there may be tooltips here because the plan is to add some tooltips so that you understand what you're doing. Right now, there is no tooltip, so it might be a little confusing. So we'll go over it really quickly. So for classes, that's how many different types of authors you want to distinguish from. So we have 3 different types of classes. The 3 class is distinguishing from human versus ChatGPT 3.5 and ChatGPT 4. And it only works with 3.5 and 4 at this point. So you're trying to figure out if you can predict an author based on whether or not they're human, ChatGPT 3.5, or ChatGPT 4. A 2 class would be human versus any ChatGPT. So that would work if you had a data set filled with, say, 100 human authors. Doesn't matter how many documents each author has produced. And say you've got 100 ChatGPT 3.5 and 100 ChatGPT 4. Then the model will be built with the idea that you'll be able to predict whether or not a document is written by version 4 of ChatGPT, 3.5 of ChatGPT, or whether it's a human. And then, of course, there is the all. So that means you're submitting a data set that includes multiple documents from each author. Usually 5 to 10 works best. So you've got 5 documents from Dr. Chang, 5 documents from Dr. Kuo, 5 documents from me, 5 documents from Joe Blow, 5 documents from Weber, and then 5 documents from ChatGPT 3.5, and then 5 documents from ChatGPT 4, or 100 of each. The point here is to try to make sure that you keep it relatively balanced. You want to make sure that there's approximately the same number of all authors across the board. And there's some ways that we can control that otherwise, but it's not good if you have, say, 5 of Dr. Chang, 5 of this author, 5 of all authors, and then 250 of ChatGPT 3.5, and then 250 of 4. You want to make sure that they're all more or less the same across the board within, 1 or 2, or, relatively speaking. So if you've got 115 of one, 125 of another, 100 of another, approximately similar. Anyway, so 3 is to differentiate between human, ChatGPT 3.5, and ChatGPT 4. 2 is to differentiate between human and ChatGPT. And all is, of course, all authors. You're trying to determine who wrote a specific document based on, or you're trying to determine the specific author for a specific document. Okay, min docs, this is one of the ways that you can control the number of documents that are included in the data set or that are trained. So if min docs or max docs is set to 0, that means you want to include all. So 0 just means all. However, if you set min docs to say 5, that means the requirement to be included in the data set is that a specific author has to have at least 5 documents to be included. So in this data set here, only this one here would be included because there is 5 documents from ChatGPT 3.5. None of these other authors would be added to the model. They wouldn't be trained. So keep that in mind when you're building, but this could be handy if you say do have 200 of one, 100 of another, 5 of another, and then 25 of another, and then 15 of most other. You could set it as 5 across the board. right? So that as 50 across the board. So it would only include the ones that are 50 or above. And then max docs is very similar in that it will only include, so if you have max docs at 2, for example, it will only include the maximum number of authors or the maximum number of documents per author of 2. So for example, in our data set that we're working with right now, let's just bring that up again. So if we had max docs set at 2, it would include this one, include this one, include the singles, that's fine. This one already has 2, that's perfect. Well, in the case of ChatGPT 3.5, there's 5 documents. So we're telling it that we only want to include 2 of them. So it will randomly pick 2 to include. So again, this is another way to control, keep your balances well. So you've got your minimum docs and your maximum docs. So yeah, if you've got a variety of different numbers, you can just cut them off at certain levels and make sure you're only including the ones that have a minimum number of docs. Okay, perfect. So pretty straightforward. I hope so. And then we've got our train ratio. So this is training versus test data ratio. So where it says 80 or 80% here, this means that 80% of the documents that we submit will be part of the training group and 20% will be part of the test group. So in our data set, let's just see what that looks like again. So in our data set, we'll just say we're doing a model 2. So if we're doing a class 2 model, if we're doing a class 2 model, that means we're comparing human versus ChatGPT. That means it's going to grab all 5 of these human and all 5 of these ChatGPTs. Now, if we have training at 80%, that means it's going to randomly pick 80% of our human and 80% of our ChatGPT to be our training data. That's the data that's going to be put into the TensorFlow model and trained. And then it's going to take the other 20%. So randomly, of course, this is all picked randomly. It'll take 20% of the human and 20% of the ChatGPT. That'll be our test data. And that's the data that it'll use to test to see how accurate the model is. So something to keep in mind. Now, we have experimented with 60, 70, and 80%. 60-40 seems to work really well. So that would mean in our case, it would grab three human at random, and then the other 2 would be training. But you can see how this could cause problems, right? But it's random, it's completely random. So if you've got 2 authors, or one author that creates 2 of the documents, and 3 different human authors that create the other 3. But the more data you have, the better this should work. And the same with ChatGPT. So in a 60-40, this would be our training data, and then the 40% would be our test data. All right. So auto, this one's a little tricky. So this one tells the trainer not to use auto validation. Auto validation is something that's built into TensorFlow that allows the system to automatically separate the training and test data, ignoring what we're doing here. So in our data set, so if auto percent was set at, we'll say 20%. If auto was set at 20%, that means it would automatically, the TensorFlow would automatically separate the training and test data for us. It's still going to separate our test data for later verification. So in other words, we still want to have this value here. Whatever's left for our test data is going to be used for later verification over and above everything else. But this tells it to use the auto validation feature built into TensorFlow. So again, looking at our data set, that would mean for 20%, it will automatically, so our system will separate out the 80%. So we'd get 4 randomly chosen of the human, and then it'll take 4 randomly chosen of the GPT 3.5, and then the auto validator will further take out another 20%, it'll approximate, for its own testing procedure. So in essence, you'd only be training 3 of the 5 of the human here and 3 of the 5 of the GPT. I don't know if that makes sense. I hope so. You're always welcome to send me messages if you have questions, and I can show you more detailed version of what that means and how it works. And then your threshold value is how long you want the model to train based on its accuracy. Now, accuracy is a little bit of a misnomer in that it is the accuracy of, let's just say it's how well the model thinks it's doing. So, and there's, if we set this value too high, if we have the threshold at above 100% or at 100%, sometimes even 95% is too high, sometimes even lower is too high, it just depends. It's something to play around with, but it means it will stop when it reaches a certain threshold. I typically keep it about 95%. For what we're doing here, it seems to work really well. That means we're usually not going to be overfitting the model or overtraining. So play with it if you want, but yeah. All right, and the other important thing to note here is the POS model types. So we're creating distribution graphs and distribution graphs of the POS types or POS combinations. So a POS is a part of speech, which is noun, verb, etc. And then there's combinations of different, nouns plus DTs plus verbs plus whatever. So in the top 5, of course, it's just going to do a POS distribution graph of the top 5. And then top 15, and then top 50. Now, this will apply to all of the models that you've chosen. So if I just choose top 50 and I choose 3 models here, they have to be different, otherwise it's going to give me an error. So if I try to select that again, it's just going to give me an error. So that means it's going to create top 50 graphs. Top 50 is generally the go-to anyway. Creating all 3 can take a little bit longer. Top 50, you're going to get better results generally with your training. We kept it here because it's kind of a legacy thing. Yeah, so, and then it will create top 50 graphs, and those graphs are going to be what's used to train the model. So each one of these graphs is going to represent one of the documents in the data set that you provide. Perfect. So I'm not going to build all 3 of these models right now because I think that would just take too long. We're just going to build, we're going to do a 2 class because a 2 class is usually pretty quick. That means we're just going to compare the human authors versus the ChatGPT authors. And in our case, we have 5 ChatGPT and 5 human. We've got our data. Yeah, so let's add the model. Perfect. And it's only going to create top 50 POS distribution graphs. So, and then we're going to upload our data set. It should give us a message. In this case, it was successful. So file uploaded successfully as test.ttl, and the new database test has been created successfully. So if this was not successful, of course, it will tell you, it will reject it, and then you'll have to try again. It could be related to your data set name or how your data set is laid out. It should give you a description of what went wrong. Anyway, once it's uploaded, you should actually see it appear on the bottom here. So it's saying that it's pending. Now, this system is set up so that every minute it checks to see if there's approximately every minute there is data sets that it needs to process. So you'll see it's actually started processing here. So it's going to take our data set, it's going to parse out all of the different n-grams and identify all the different POS or parts of speech, what's a noun, what's a verb, and then find all the combinations thereof within each document, and then put them into our database. It actually creates a database, then puts it into the database, and then it's going to create the chart images. So the chart images, again, are the POS distribution graphs, and that's what we are building our model off of. We are not actually building the model on the text itself. We're building the model on the POS distribution graphs. So it'll create the model or create the graphs, then it'll rename the graphs, then it'll generate the model. So generating the model can take some time. It didn't take very long in our case because we really didn't have much of a data set. It's actually just and we were only doing top 50, so it actually only had 10 graphs, and it was trying to create a model off of 10 of those images. So now that it's done,